Good afternoon, everyone. Before we begin, I would like to point your attention to the Ask Question button on the right-hand panel of your screens, wherein you can submit your questions throughout the session. Please feel free to ask as many questions as you like, and our panelists today will try to answer them as time permits. All right, with that out of the way, welcome to the Future Developments for Additive Manufacturing Southeast Asia webinar. My name is Stephen Las Marias. I'm the editor of Asia Pacific Metalworking Equipment News magazine, and I will be your moderator for today. As you may all know, this is the second part of our two-part webinar. In our previous webinar, we featured SLM Solutions, Siemens, and Global Data, who spoke about the different additive manufacturing deployments in Southeast Asia, the process challenges, and the key considerations towards successful adoption. Part 1 also looked at where the pandemic has left the additive manufacturing industry this year and the many developments enabled by additive manufacturing to help the fight against the pandemic, thereby showing its flexibility and agility it provides manufacturers in their efforts to help the industry address their requirements in these extraordinary times. Our panel discussion today will pick up on that and focus on why additive manufacturing presents a unique opportunity for your manufacturing, what it can do for your design, operations, and innovations, excuse me, and how it is a strategic differentiator in today's manufacturing environment. First, I'd like to introduce our experts for today. Our first panelist is Gary Tang, Sales Director for Southeast Asia at SLM Solutions Singapore. Gary? Would like to see your face and Hey, Gary.
Hi. Hi, Stephen. Thanks for that.
Yes, maybe Gary, you can tell us. All right. Okay, please go ahead.
Yes, a very good afternoon to everyone. So my name is Gary Tang, and as Stephen introduced, I'm the Regional Sales Director from SLM Solutions Singapore, based here. This office here basically oversees Southeast Asia, Korea, and Japan, and really very happy to be here, to be one of the panelists. Just a quick introduction for those who don't know. So SLM Solutions is the pioneer for selective laser melting technology, and of course the technology innovator in this space. So looking forward to a very engaging discussion. Thank you.
All right, thank you very much for that, Gary. Our next panelist is Li Chen, Application Engineer for Asia Pacific at Markforged. Li Chen?
All right, Eric, can you see me here?
Yes, we can see you now, Li Chen.
Okay, hi, good afternoon, everybody. My name is Li Chen. I'm working for Markforged as an application engineer station in Singapore. So my main job is supporting both ASEAN, the Southeast Asia region, and also Greater China region. So it's very happy to be here to have some fruitful discussion soon. So I'm actually right now standing in my partner's kind of like so-called digital factory. And behind you can see is our Sinter 1 furnace. So if you want to see some parts, actually they are also on my hands surrounding me right now. So yeah, looking forward to talk to you guys.
All right, great. Thank you very much for that, Li Chen. And then our next expert is actually James McHugh. James, he is the Regional Director for Asia Pacific at Universal Robots. Excuse me. Based out of Universal Robots regional office in Singapore, James oversees the company's China, Taiwan, Japan, South Korea, Singapore, and India operations. James, can you hear us now? Let's just give James a few minutes to set up his system. James? All right, we'll get back to you, James. Finally, we have Dr. Ho Chao Sing, Managing Director of the National Additive Manufacturing Innovation Cluster, or NAMIC, which is Singapore's national additive manufacturing accelerator that implements breakthrough strategies for the future of production by additive manufacturing technologies. Dr. Ho?
Hi, Steve. Hi, everyone. So yeah, thanks for having me here. So my name is Chaw Sing, and I oversee the National Additive Manufacturing Cluster. This is actually a Singapore national platform that is supported by the National Research Foundation under the Prime Minister's office, and we do a lot of work in partnership with the economic agencies. The main area we look at is to increase Singapore adoption of additive manufacturing technologies to enhance its competitiveness with rapidly evolving landscape of industrialization. And we actually do this by acting as a connector between industry, research performers, and public agencies. We also identify and nurture promising AM technologies and companies and orchestrate public-private collaborations. Looking forward to the discussion today. Thanks for having me.
All right, great. Thank you very much, everyone. And actually, I would like to invite all of you guys to turn on your videos and audio. Okay, perhaps I spoke too soon. I would like to introduce James first. He is now here to join us. James is the Regional Director for Asia Pacific at Universal Robots. He's based out of Universal Robots office in Singapore, where he oversees the company's China, Taiwan, Japan, South Korea, Singapore, and India operations. James, maybe we can just tell us a little bit something about yourself and the company.
Sure. Thank you very much, Stephen. Great to be here. I'm Australian originally. I've been living in Singapore for the past 2 years. Been involved in automation and power for the last 15 or 20 years, and with Universal Robots for the last 2 years. Universal Robots, I think this week we delivered our 50,000th cobot. So as the kind of first mover in industrial collaborative robots, I guess we've kind of set the standard over the past decade or so. I think the alignment to additive manufacturing is good, because what we see is in our differentiators is flexibility and rapid deployment, and I think there's a that we have in common with additive manufacturer, and increasingly it's helping us deploy our robots faster for our customers. And I also think, frankly speaking, that there are huge opportunities for the manufacturers of additive technology as well as collaborative robots. So it's going to be a good discussion. Thank you.
All right, great. Thank you very much for that, gentlemen. All right, let's start with the burning question. First, why do you think additive manufacturing presents a unique opportunity? I'd like to maybe point to Dr. Ho first to answer this, and then we'll go around the table.
Sure. Thanks, Stephen. So I think for us, additive manufacturing itself is it enhances the flexibility and efficiency of manufacturing operations, as well as the supply chain. And on top of that, it also facilitates new concepts such as circular design. This means that enable companies to create products and services in a sort of a more sustainable fashion. And of course, in a lot of ways, it contributes to us as a country to us to become a more innovation-led economy. The other thing about AM is, of course, it bridges the physical and digital divide. And when you combine with other technologies such as artificial intelligence, machine learning, or robotics, is what James has alluded to earlier, it offers actually unprecedented efficiency and breakthrough in the way we produce products in the industrial space, including the construction or built environment space. You can utilize the recycle or upcycle waste materials, from plastics, fish nets, or even chitin from, shellfish, to replace even conventional materials for use in production. An example, some of you may be aware, I think 2 years ago, NASA actually held a space habitat competition. What they did was there were companies that came forward to develop robotic systems that could harvest materials from the terrain to create a special feedstock that can be used for automated habitat manufacturing. And this is meant to be deployed on Mars long before any manned mission is actually taking place.
All right. Gary, would you care to share us your insights on that?
Sure, no problem. I probably just want to start out with this quote that I read somewhere. It was from I think it was a McKinsey report. It says that we will be facing more disruption in manufacturing in the next 5 years compared to the last 20 years combined. And that's exactly what SLM is trying to do with its technology, is to work towards industrialization of additive, or in this case, metal additive manufacturing. And so what that presents really is the ability to reduce, of course, lead time, whether you're talking about prototyping, do away with almost most, if not all, of tooling and fabrication, which of course takes up lots of time and money. Able to industrialize production using AM, so you're able to come up with designs and basically engineer new products that conventional manufacturing probably wouldn't be able to do. And of course, last but not least, it provides another opportunity to digitalize spare parts, in the sense that you can create a whole digital warehouse of spare parts where you print on demand, from the cloud anywhere in the world. So I think that's my perspective.
Right. All right. Thank you for that, Gary. Li Chen, from your perspective, what can you say about why AM is presenting a unique opportunity for manufacturers right now?
Okay. Because most of the time, actually, I'm more on the ground together with my partner to talk to some prospects or some existing customers. So after that, actually, from years collection of those data, we try to figure out that why people start to look at additive manufacturing and start to talk to us. And generally, we were categorized under maybe around 5 categories. So in the very first stage, 5 stages, that way. So in the first stage, probably people looking at only like part-to-part comparison to have like a cost reduction. And that cost could be like a labor cost reduction, lead time reduction, or purely the cost of the material reduction. And then after that, then people maybe look at for more on the supply chain problem, especially in the pandemic situation right now this year. So more people actually come to additive manufacturing to seek for solution. Maybe perhaps they're not sure also, but perhaps there will be some solution for them to solve their current supply chain breakdown problem. And then on the third stage, people look at like the more the better agility and the responsiveness on the production in general. And then in the fourth, they will look for design performance. Means like just now what other gentlemen mentioned is about design for additive manufacturing, so that in general make the whole production be more efficient, or it shows the better or higher advantage of additive manufacturing. And then the lastly probably is to people maybe the higher management see the value of additive manufacturing, and then they start a new business model of using additive manufacturing purely for their end customers. Yeah.
All right, great. Finally, James, from your perspective, why do you think AM can be a unique opportunity for manufacturers? I mean, from your conversations, what can you tell us?
Look, I think that the other panelists have summed it up well, but it's that flexibility that, when we talked about how cobots kind of revolutionized robotics because of their ability to be rapidly redeployed as opposed to, long production runs. I think additive manufacturing, whether it's being able to customize your Nike shoes with different soles as an example, but they're shorter, sharper production runs with much more customization. I think it allows manufacturing to, this post-COVID age to be able to at a price point come back to many high-cost countries and provide, unlimited flexibility and customization. And I think that's what we're seeing is a lot of our customers actually, in semiconductor even, they'd rather print an end effector for our robot, because the chips can be quite abrasive, and it's more efficient to actually just be able to build your own end effector. You know your business exceptionally well. They can make adjustments and improvements over time, and they can do so very quickly. And as I say, no inventory. You're holding. You only incur the cost when you say print. So I think this customization, flexibility, and adaptability are key to how this will transform manufacturing.
All right, great. Thank you very much. You mentioned cost. My next question would be about cost. Definitely one of the key issues right now in 3D printing is still the cost of the printers. For example, for the small and medium-sized enterprises here in the region, Southeast Asia, how would you think it will make sense for them to justify investing in 3D printing technologies? Maybe Gary, can you please start on that?
Sure. I think it's a good question. I think just to give a perspective, there's a spectrum, right? On one end, you have probably the big MNCs with all the budget, and they're able to invest in-house and do all the R&D before they make a decision. And on the other hand, on the other end of the spectrum, like what Stephen you mentioned, there might be SMEs or even smaller companies that understands the advantages of AM, but don't know where to start or may not have the huge budget. And so I think that's where partnering with the right people, partnering with the right partners, with the right companies, forging those partnerships is very critical in this AM industry, because at this point of time, no one company knows everything, to be frank. It's still a very fast-growing technology. In 2 years, 3 years' time, a lot of things that we know of will probably have changed. So I would encourage SMEs to approach companies or approach NAMIC or anyone that's able to just help you, just work out what is it that you really need step by step as a start, because it's not as simple as just buying a hardware and you literally plug and play. Definitely not that simple. But yet on the other hand, you do need the right people and the right maybe organization and network to point you in the right direction. Just to quote you, there's a survey that was done, and it says the number one obstacle in why companies do not want to adopt 3D printing is purely because of technical know-how, because they don't know what is it really all about. They don't know where to start or how to start. And I think that's where we need to provide, whether it's through service bill, through services, through government agencies, or even like companies like SLM Solutions. We provide just starting consultations, just to help you with the feasibility. So I think things like that would be a very good starting point, so that you don't jump both feet into the ocean.
All right. On that note, with the help, seeking the help of government organizations, maybe Dr. Ho, you can answer that from your perspective as NAMIC.
Yeah, I think in addition to what Gary has mentioned, I just want to address the point about the costs for SMEs. I think a lot of people think about cost as in a direct part replacement. So you're basically using AM in replacement of or substituting a traditional manufacturing method. But the truth is that for us, when we look at the application of 3D printing, we look at the whole end-to-end value chain, starting from the start of the product life cycle, if possible. So where AM does make sense is where you need a relatively short lead time, and we've proven this in many cases, whether you're actually printing a propeller for ships, or you're doing medical supplies for test kits, such as nasopharyngeal swabs, for example. So I think when we look at cost, it has to be a kind of a holistic perspective. It's not just one-for-one replacement. So that's one part I just wanted to mention. This. The other thing that before I talked about how we support companies is that I think for SMEs in general, especially the space that a lot of companies in Singapore are in today, they do a lot of white label manufacturing, or they do component manufacturing. And what we believe is that this technology, in some ways, if you have to write partnerships and the setup that Gary sort of mentioned, it will help the companies to move up the value chain, right? In terms of even potentially disrupting incumbents with the traditional products and designs. So what we do as a national accelerator is that we are extremely sort of an industry focused. So for us, we don't push the technology upon the companies. What we do is we have a very sectorial level approach. So for example, we look at all the leading industries in Singapore, such as maritime, marine offshore, even the aerospace MRO, as well as even potentially new offshoot industries that we believe Singapore will have a major role to play in, such as in the healthcare space. And what we try to do is we develop a design thinking process where we sort of understand what the company really require in terms of where their business wants to be. So there has to be a business value proposition in applying a technology or solution, right? Whether it's additive manufacturing or robotics or artificial intelligence. So that's the premise that the way we work on. And if once we find that value proposition, we will then find the best research performer in our cluster of universities and research institutes, where we will fund the projects basically to develop the solution for the company.
All right, great. Thank you for that, Dr. Ho. Lee Chen, from a Markforged's perspective, what can you say to that regarding the cost consideration when it comes to 3D printers?
Yeah. Okay, my turn. So I let me share some of my thought first about cost saving, or like when we first time, let's say, talking to customer. I believe both Dr. Ho and Gary will agree with me that when we first saw the part, the customer pass us a part saying that I want to use 3D printing to print that. Then we saw the part. The worst thing that we saw is straight away we see that, oh my God, this is injection molded part. Oh my God, this is a CNC part. So starting from design, we straight away know that it is not very favorable for additive manufacturing. And with that start, it's very difficult for us to implement or tell the customer that you should use that because we can see the value. So I would say selecting the part in the first place would be very important for everyone to try to adopt this technology. And that first impression will give you the understanding that where can be used and where cannot be used on additive manufacturing. And then another angle I want to say is from our industry, the technology itself. For additive manufacturing, actually, right now we can say that including non-metal printing and metal printing, and so many different brands and so many different kind of technologies. All of the brands and technologies able to last for years and decades. There is a reason, which means that actually not all the there's no one technology can use for compensate all the different situations. And also in terms of the cost, definitely maybe start from plastic or non-metal printing will be cheaper in a way, but still, as a user themselves, they have to ask the question about which technology is more suitable. So then from there we can see the cost, and also cost, like the first question you asked, that I answered that. The first cost is actually a combination of the part cost, the lead time, and also this the whole supply chain. So you may see the additive manufacturing, maybe let's say you can save the inventory cost, and that is actually a secondary cost saving that would not be directly reflect from one part. So you need to see from the whole view, in my opinion. Yeah.
All right. James, do you have something to add to that from your perspective?
Look, I'm not an expert on additive manufacturing, but what I do see is huge similarities between additive manufacturing, and the traditional way of, machining or injection molding, and from UR's trajectory, we disrupted industrial robots, and we did so on a similar basis to what you're talking here about understanding the whole value chain, speed, ability to redeploy, and an ability to talk to robot users and get them enthused, and talk to robot buyers and get them understanding the economics of the investment. As you point out, printers last a very long time. There's a massive depreciation benefit. The flexibility that would unlock. I really, interestingly enough, our president, who took you from 10,000 cobots to 50,000 cobots, is stepping in as the CEO of Ultimaker as of the 1st of January. So he kind of, for me, I see him he has that vision of where additive manufacturing is going, and it is kind of going to be the next very, very significant growth part of manufacturing. And I really think that the big guys, the multinationals, they'll just buy it as they did with our robots. But the mass market to SMEs is where the real explosive growth is. So the big guys buy it. That kind of creates impetus in the smaller guys to not be left behind, and actually a real inquisitiveness to say, how can we do this? That normally comes through operators, who then need to be able to be supported by the manufacturers of this equipment to talk the economics to their people within their business. So, I mean, I have no doubt that in the same way that an SME can afford a 30,000-40,000 euro robot, they can, or cobot, they can certainly justify the investments of additive printing when you get the whole value chain right.
All right. Thank you for that, James. Actually, my next question is for you. It's for you. Because I read somewhere that we used to have server farms, right? Now I read that they now have 3D printer farms, and it was related to, I think, robotics. And from your perspective, James, how does collaborative robots, where does 3D printing fit into Universal Robots' strategy in this regard?
Well, we most of our robots in Asia Pacific are solving various labor variability problems, and they're different in each country. People buy factories, they want to get utilization. That discussion is different in China to what it is in Vietnam or Korea or Japan or Singapore. So we see this kind of exciting opportunity in that these printers allow our integrators to be super adaptive and be able to customize end effectors and do it very cost effectively, which makes the whole integration a better solution. But when it gets to, I guess, if you like, printer farms, they're not that dissimilar, frankly speaking, to these, in the automotive industry, where you have massive CNC milling operations. And these days, the generation coming out of university now don't want to tend CNC machines, and I don't suspect they will want to tend 3D printers. So we see the ability for our cobots to play a role in tending printers as a huge growth opportunity for the cobot space as well.
All right.
Sorry, Stephen. Could I just add a couple of comments?
Yeah.
Is that okay?
Sure.
Yeah. I think the many customers that we see, I think that's definitely one of the number one things that they ask is cost. And like what all of us have commented on, it is true. Upfront, at least from a metal additive, metal AM perspective, the two key things that people will point out will be the cost of the machine, the investment, the capex for the machine, and maybe the material, which is the powder. But I think kind of like what Dr. Ho also alluded to is that, but if you really look at it an entire supply chain from end to end, so if you talk about the amount of lead time you reduce from what used to be 6 months, you reduce it now to a day in terms of production. You remove the tooling, fabrication, and that can cost a lot depending on what you're making, along with the rapid response to market design and market demands. So you're able to change very quickly. Right now we have some customers that's talking about how they want to upsize their printers because they're not seeing enough speed and productivity from some of the current machines that they have bought maybe a couple of years ago. So that just goes to show that if you are able to hit that sweet spot, okay, cost suddenly will drop as a consequence of having all the right steps that you take, the right parameters and the right design, the right parts, like what you all mentioned. So it's really making sure that you go down the right path and having all the things line up properly. And then if you do that step by step, costs will eventually be in my words, you will hit that sweet spot according to what you're trying to manufacture.
All right,
Yeah.
great.
Yeah, if I may as well, I think Gary just triggered some thoughts in me as well. I think not just talked about cost, but when you even in the current situation where you have these COVID-19 pandemic, I think a lot of folks might recall that I think barely 6 months ago, there was a global shutdown, right? Literally. So with this kind of black swan events, what the community here in Singapore, and I think also reflected in many countries in the world, has been able to do is to actually activate 3D printing capabilities to manufacture actual medical products that's required. And actually at the peak of the crisis, and I used the nasopharyngeal swab, which is used for tests for COVID-19, the viral. So this nasopharyngeal swab, the original manufacturers were based in Lombardy in Italy, and I think back in March there was basically Italy was at its peak of infection. The whole manufacturing was shut down. So one swab, went up from 70 cents per swab to something like $4 or $5. And what we found out is that with 3D printing, even though it would generally be costlier to produce, we could be able to actually manufacture this at $150 per unit. And so in this kind of situation where there is a disruption in supply chain, and I think this is where a technology like this can add this layer of resilience and flexibility, I guess, to ensure there's no local shortage of some of these critical supplies.
All right. Yes, I remember one of the case studies presented at the part one of this webinar last November 24. It was Siemens who presented on a face shield that they were able to manufacture using additive manufacturing, based on the design by a hospital in Singapore. And then they were able to do everything in a very short time as compared to doing the molds and then doing injection molding. So I think it's that's one of the things that additive manufacturing has sort of underscored during the time of this pandemic. All right, moving
Absolutely.
on to my. Oh yes, please go ahead, Dr. Ho. Yeah, you were saying.
No,
Dr. Ho?
I was concurring with that. I think just to remember that this is a technology that's is a digital technology itself. So from a digital design, you can basically translate to a manufactured product, as opposed to all these against the intermediate steps that you would have to go through, like tooling and the qualification of molds and things like that in the traditional case, which typically takes much longer to set up.
Right. All right. Thank you for that, Dr. Ho. So from your perspective, maybe let's start with Dr. Ho. Will we finally see a high volume additive manufacturing?
Yeah, I think if you look at some of the products today, for example, like hearing aids, dental aligners, these actually have been already mass produced with additive manufacturing technologies. And the reason for that is because these kind of products typically require some level of mass customization, and it just cannot be traditionally produced in a very efficient manner. Someone alluded just now to footwear. I think footwear today, you may know Adidas have already launched 3D printed insoles with the shoes. This is a collaboration they have with Carbon 3D, and they're actually scaling up, and they're able actually to produce it at a cost level that is very comparable with what they do, what they have traditionally with manufacturing. One of the things that maybe I would say is for high value parts for products that basically there are that has obsolescence issues, where either the manufacturer has gone bankrupt and you're not able to source it anymore. This is actually a fantastic technology where you can actually recreate the part on demand. And of course, in most cases, I would say beyond the use of it in product development, so it shortens the product development cycle time. It's used very much in cases where you pluck a pandemic or a black swan event, like I mentioned earlier, where you need to go for short production runs until you're able to then qualify the traditional manufacturing to get it up and going. Because from the economics of the technology itself at this moment, again, depending on the kind of part that you are talking about, so if you're able to do part consolidation, which means that from a product design that traditionally would need to source from multiple sources and then you bring to a assembly house to reassemble, you're able to print it in one design. That sort of thing, obviously, makes sense to produce, with additive manufacturing. And there are many cases that is now many use cases that have now been demonstrated that you can actually use this technology for serial production. One of the hurdles that I would say, I think because we've been sort of veering on cost, is actually not so much in cost. One of the hurdles today is that a lot of the high value products that we're talking about that's suitable for additive manufacturing are in sectors that are highly regulated. So we're talking about aerospace sector, we're talking about biomedical, healthcare, even the marine offshore and maritime sector, right? All the parts that are printed or fabricated needs to be certified and make sure that they are fit for use and for deployment. So this is an area that I think I would say largely the community in the last 4 or 5 years or so have stepped up. I mean, we have developed, global community have developed standards to improve the repeatability of parts that are manufactured using AM technologies, and that's something that will continue. I would say continue to progress. To gain confidence, and especially in these slightly more conservative communities, especially like healthcare, for example.
Right. Okay, great. Thank you very much for that. I'd like to get Lee Chen's perspective on the question. Are you seeing high volume additive manufacturing now?
In terms of Markforged, actually, I would say the answer is yes. Because for differentiating our brands versus other technologies, it's mainly talk about the performance, which is the strength of the material. And because that strength of material, we are able to handle some of the parts that have been printed and be real use as either tooling or end use. And all those parts actually, we have actually one example. We have one customer, and we are dealing with them on a production, which is a roller in the conveyor. And they are a water manufacturer, and they have many plants in like Indonesia, and Singapore, and even China, etc. So, for people who are not very familiar about those industries, actually water manufacturer, in order to let the water pump into the bottle and then manufacture like bottles and bottles, actually the conveyor spinning speed is extremely fast. Then imagine one of the roller in the whole conveyor breakdown, then they have to pause the conveyor and then to do the replacement. And if let's say they just pause for just let's say 10 minutes to resume the whole production, and in that 10 minutes, they're able to produce 6,000 bottles from one conveyor. And that 6,000 bottles is the selling price. Let's say it's $1 Singapore. There is $6,000 selling price. So if we can make the performance become even higher than what they expect on their current rollers, we can do the job. Right. Although maybe some of the parts, for example, the roller could be like the same cost, you won't have a very significant cost saving on that particular part. But in the result, actually, we start to do the testing in this year, February. Until now, actually, it already lasts for 11 months. That shelf life is actually longer than their original part. And that original part roller itself is made by a PU material. And now we use our Onyx with the Onyx material with a glass fiber reinforcement. The composite material give the performance even higher. So what I'm trying to say is sometimes actually people will come to you as say, I have a problem, I want to improve, but they don't really care about what exactly the detail, like material or process they're doing. But you have to show the performance. And once the performance goes, is able to justify for a huge volume. So in that case, I would say yes, we can do high volume, and that high volume is also justified for a very quick ROI for doing a 3D printing in-house. Yeah.
All right. Okay. Yeah. Yes. Dr. Ho mentioned something about medical earlier on, and then I remember one of the articles we published at the Asia Pacific Metalworking Equipment News magazine is about the medical side for additive manufacturing, and it's one contributed by SLM. From your perspective, Gary, what else can you say about the possibility or the high volume manufacturing being done through additive manufacturing or 3D printing?
Well, the answer is definitely yes. We have big MNCs right now working with us that are pushing and asking us to do a lot more than what we're able to catch up in terms of technology. But I'll share a little bit more later. But I think one example to really give is the automotive industry. That's definitely a high volume industry. So we have been working many years ago with a very popular German automotive manufacturer, performance automotive manufacturer, and they have been printing brackets. Of course, metal brackets. It used to be plastic injection molded. So that has really been successfully printed up to 60,000 parts. And with that high volume of 60,000 parts, it is already what we call profitable, meaning that they're able to price the cost of that of each of that part is already lower than what they usually get from plastic injection molding. So what that means is that what people think that 3D printing is only for by the hundreds, by the thousands, maybe it no longer holds true, to be frank, because of the technology right now. So like I gave that example, 60,000 parts. That's already quite a big number. But going forward, I can safely say, like what Dr. Ho mentioned about hearing aids, implants, dental RPDs and all this. I think these are all just right at the forefront because these are the early adopters, right? Aerospace, medical, automotive, three are the key big adopters of AM right from the beginning. But as we start to see more of these industries coming in, so-called oil and gas, marine, these are big. Some of them are typically bigger parts. Maybe even in just the general heavy industry kind of sector. We will definitely be pushed, even if we don't want to, we will definitely be pushed to move into high volume manufacturing.
All right, great. I can't help but notice one of the questions from our audiences, and I think this is for Universal Robots, James. So the question from Kai Lun Chin is: are there actual case studies of successful implementation of cobots deployed in partnership with 3D printers? James?
A great question, thank you. And look, the short answer is I haven't seen us do one yet, but having participated in this forum, it really is something we should do because we are working with companies who are using a lot of 3D printing. Whilst we don't see a lot of mass production, 60,000 units yet. We can say that pretty much every automotive supply chain partner that we deal with for Tier 1 Auto, all of them are using the technology, or even if it's to customize end effectors for our robots at this point. So, yeah, I think that will be going on my to-do list following this meeting, is to get my Singapore marketing team to find a good case study to develop on the value proposition of the printer and the robot.
All right.
Yeah, maybe
great.
Maybe I can also add to that is that I did mention that there is a great synergy between combination of these different technologies, robotics together with AM. So I think in our case we've actually developed a few number of large format robotic 3D printing systems. So think about it, these are like it's just a robot arm integrated with extruder, right? And then of course a heat source, right? Whether it's an arc or source or laser source. And this has been deployed for the maritime marine offshore sector, where you require extremely large parts to be printed, basically. And the other point I wanted to mention is that along the line about manufacturing or the manufacturability of such systems is that by basically changing some of these variables, like for example, changing feedstock from powder feedstock to wire feedstock, you can reduce costs at a very very big quantum, right? So we're talking about for cost comparison between powder and wire for the same type of material can be anywhere between a few $100s per kilograms to down to $3 per kilogram. So that's a huge sort of cost delta, and we see a lot of interest from the heavy industry sector, because the fact is that we are able to bring the cost down. We're able to demonstrate automation with this technology, as unlike what they traditionally do, with the casting and forging, which typically takes them months and to deliver.
Mm-hmm. Yeah. Thank you for that, Dr. Ho. Gary, I understand SLM is the inventor of the selective laser melting technology, an inventor. And then how could you share with us how it will sort of impact the development trends in 3D printing?
Sure, no problem. Well, as you probably know, powder bed fusion, laser beam powder bed fusion is really what we call in the widespread industrial use, which means that in terms of its technology index, the maturity index is pretty stable. So some of you may or may not have heard, but on 10th of November, SLM Solutions actually launched what we call our next gen machine, which is really the we call it the NXG 12600. So what that really translates to is that it is our 12 laser machine, each laser with 1000 watts and a huge chamber of 600 by 600 by 600 mm. So what that does is that it's exactly what I mentioned just now, is what many big MNCs have been asking for, which is to push the whole envelope, the whole threshold of high production printing into a completely new space. And this is what it is, what has been delivered after years of development with some of these strategic customers and partners. So the impact you'll see is that what used to be really big parts, what used to be expensive in terms of part costs because of just the sheer size and the volumes that we're not able to achieve, now is achievable. That means that now we're able to print bigger parts. The part cost for each would be on par, if not even better than before. And this is all obviously all done in conjunction with many of these big industrial players, whether it's from aerospace, automotive, and energy. So what we see as our next gen machines is really basically the next how should I say that, the next breakthrough, the next game changing technology, or not technology, but game changing machine that we see that will partner with those customers, those companies who really want to adopt high volume series production, and that's something that we're really excited about as we get ready to work with customers in this region on this next gen machine.
All right, great. Thank you very much for that, Gary. This is related to one of the questions by the audiences as well, but we will get to that in a bit. So 3D printing, there's some metal, there's plastic, and then earlier on in one of your answers, Lee Chen, you mentioned something about composite materials, composite technology, composite printing. Can you tell us more about that and the opportunities that particular strategy or technology will provide 3D printing?
Yeah, glad you asked. So actually, for people who are not aware or not very familiar about Markforged, we're actually a US company that based on the technology that printing composite, which is carbon fiber, and also metal printing. So the first year, which is back to 2013, we start our printing technology, founded this company with this continuous carbon fiber reinforcement technology. And that is actually, I would say, in current way that when people talk about additive manufacturing, still looking at either plastic printing or metal printing. But we are actually in the middle of this plastic and metal to give relatively stronger strengths comparing with normal plastic printing, but also kind of like a easier process comparing with the metal printing in a sense. So a lot of people actually looking to Markforged solution is because the composite printing technology really can give them certain performance and very easy to use. So our mission for helping all the manufacturers is to make the manufacturing process being more and more less and less complex. That is our driven. So if you happen, because I also see some of our customer in the audience leads. So those people actually, once they experience about how they use about Markforged, they should know that how easy this whole process is and how constant the result could be. So yeah, that's it.
All right. Yes, and related to materials being used in 3D printing, one of the questions from the audience, Gokan Gurkan, powder prices are still so high and not easy to find many suppliers. From your perspective, maybe Dr. Ho, Gary, or Lichen, anyone of you can answer. How can this be sort of addressed? Dr. Ho first, maybe.
Sure. I think the material costs and to be frank, this is not something that I would say there is an existing solution. I think with the current level of adoption and I think costs, especially for some of these metal powders will continue to be at this level. Of course, you do have these upstarts that what we call open source suppliers that may provide some of these more competitive price powders. But I think that itself is going to be the kind of the baseline that you have to work with. I wanted to kind of maybe say that from a material perspective, ultimately it's also paired with the design. So we didn't quite talk a lot about this, but I think I mentioned a little bit that when you look at AM as a whole, as a technology, we don't look at doing part replacement generally. What we try to do, and I think Lichen mentioned this as well, is to improve the performance, right, of the product. So in this case, you could redesign, in this case, for AM by applying, what we call a topology optimization. So the material itself, or the you can create these kind of lattice structures that traditional manufacturing will not be able to produce. But these are all simulated to make sure that the product itself can perform even better than what the incumbent can do. And I think this is where the cost savings, you actually use less materials, and we've seen many cases already around the world. Also from our own examples doing projects with companies, that you could actually reduce costs just by reducing the amount of material that you use for fabrication.
All right, great. I'd like to, Gary, maybe you can answer that, from a metal powder perspective.
Yeah, so just a good link from what Dr. Ho mentioned. I think the fact that if we have a proper design, or we do a proper defend, and from a topology optimization perspective, number one, you will definitely, besides getting the right design, you will have reduced unnecessary material usage from that particular design. So that's of course one way if you're talking about just purely cost savings from powder. But of course, more importantly, is really the versatility of material development. Yes, I do agree that at this point of time, the powder cost or material cost still is significant. But right now, I think it's a chicken and egg thing. You talk about like adoption, what was mentioned. The numbers, the systems out there, it's not as high as the traditional machining equipment out there. So if the demand is high, definitely the prices will drop. But right now, it's hard for anyone to say. All I can say is right now the pricing is a huge flux. It's all quite dependent on the demand, the type of material, who supplies it, and for whatever. Right. But I think the key thing really is how to make use of the right design, right kind of material development and parameters, and then to achieve your so-called ideal outcome. Because we have seen some companies that are willing to spend the money and investment to develop new materials other than the standard. I mean, we're all familiar with some of the standard like titanium, aluminum alloys, nickel-based alloys, but there are some that are really venturing into some of those what we call super alloys and all, and these are all, it takes time, but it will pay off once, literally in the long run, once you develop it. It may partially or in whole become proprietary to whichever company that holds it, and that itself becomes a huge competitive advantage. So I think, yes, there's a lot of focus and talk about cost as we started off, but ultimately I think we really still need to balance it off with the advantages that we see. You know, like I fully agree with what Dr. Ho said. It's not about buying a machine and then you compare the part price versus what I would have gotten from a conventional manufactured process. It's more than that. No, it's really investing for the future, investing in the technology, knowing that if you know that in, let's say, example, arbitrary, in 10 years' time or 5 years' time, 80% of people are all going to go into 3D printing. Are you going to choose to still not adopt 3D printing, or would you actually also start investing or getting ahead of the curve? I think that's the question. It's not a matter of if, but when.
Mm-hmm. Right. Thank you for that, Gary. Licen, do you have something to add to that?
Yeah, I want to actually continue from what Gary's talking about. It's actually 3D printing, or let's say the machine itself, is just one of the elements in the whole process, and then, as well as material. So if only purely looking at the one element, meaning that you default thinking that all the rest of these elements, like the design and the technology and the other costs or the process, will be fixed, which is not possible. Because in the future, actually, all the process, each of the elements in the whole chain will be developed at the same time, improved at the same time. So I think audience are also more like to listen about the future. What we look about the future to forecast whether the material itself will be really become the lower, the cost will become really lower and lower. To put the specific market scale, let's say in Singapore or the Southeast Asia, I would say still for the metal printing, we haven't reached to a certain level to have like a very big scale implementation or application to use in the whole Southeast Asia. Because the reason I think that is, if we're going to compare with overseas, let's say China, they already have a whole ecosystem surrounding the metal powder, a new industry related to 3D printing. So you can see some companies that are only producing metal powder, and they have different range of different grade of metal powder, which is we got good one or bad one. So the lower grade it is, actually the cost is cheaper. So I believe if it also need everyone's all the speakers and all the audience here, we need to make this implementation or the application, find more applications to use on metal printing, so that we can have a huge, bigger and bigger volume on using this technology. Then eventually you can see the whole ecosystem become more and more healthier. Then definitely I think the cost of the using will be reduced. Yeah.
All right, great. Thank you very much for that, Licen. We're now nearing the top of the hour, and then yes, I just have one more question to our panelists. And then we do have a few more questions from the audience, but I think in the interest of time, we'll just get back to you. We'll just email you these questions, the answers to the questions from our experts. So my last question, James, from your perspective, what do you think will be some of the future development trends in additive manufacturing, and how will Universal Robots position itself to help 3D printer manufacturers or manufacturers adopting additive manufacturing in their process lines? Where will you are sort of in that sort of?
Sure, thank you for the question. I think you will continue to kind of cross-pollinate our SMEs with what we see as best practice being done by some of the big guys, and talking to SMEs about how they can become more efficient, faster responders through additive, investments in additive manufacture is something I think that would resonate with our customer base too, because they're always looking to be ahead of the curve. And I think that this technology in its varying forms provides pretty unique ability to differentiate and really drive some more innovative manufacturing. So I think in the SME space, that's going to be critical. And then, the big guys, I think we're going to start to see more and more products, particularly in pharma and life science, that switch to additive manufacturers as the costs start to be better understood and not feared.
All right, great. Dr. Ho, can you tell us some of your insights on the future development trends for AM?
Yeah, sure. I think beyond the of course the natural technology evolution that's going to take place, and I think Gary has alluded to that, more speed, more throughput for printers. What we see is the cross pollination of different technologies, as I mentioned earlier. The embedding of machine learning. And in a especially for example, like even simple things like in-process closed-loop monitoring system to ensure the parts are repeatably produced. So that's one area that we think it's very important, especially to enable these future adoption that is required at a manufacturing level. The other thing that was not really mentioned too much about, I think this is also quite important, and we are looking at this as well, is automation for the post-processing after the 3D printing process. So there is actually a post-processing part that takes up somewhere between, based on our study, somewhere between 40 to 50% of the cost and the time. This includes the depowdering, removal of support structures, surface polishing, remove surface pores for structural integrity, and so on and so forth. So these are things that we think it's a very important part of the important part of the whole AM process, right? Because ultimately what the customer wants is the final product, right? They don't really care whether this is 3D printed or this is actually machine and things like that. And the last part I would say is the more integration along the line of automation is really more integration of the manufacturing enterprise systems to support basically integrating additive manufacturing into the manufacturing value chain. I think this is something that traditionally, because these technologies has always been used as a prototyping technology, so it's kind of like a standalone sitting in a lab, basically disconnected from the whole manufacturing enterprise system. So this is something we feel is needed, very much needed, in order to make this more of a mainstream solution for manufacturers.
Actually, Doctor, that's one of my questions for you, supposedly, but I just wasn't able to ask in the interest of time. But well, now that you mentioned it, I would just like to ask, because as of now, parts being built by additive processes, still more closely resemble the raw stock of a particular shape than they do the machine parts. So this means that apart from the additive manufacturing, or apart from the additive process, you also have to do some subtractive process so that you can have that final output that is you can achieve the final part. So I think you answered that. Yeah.
You're right. For the technologies, for example, exemplified by SLM Solutions, these are powder bed fusion. The final part, usually when they print it, is pretty much close to the final product itself. So you just need to, as I mentioned, do some of the depowdering, support structure removal, and even surface polishing to achieve what you want eventually. But for some of the AM technologies, like we didn't have time to talk through this, but there are many types, like the wire arc AM process, where you use wire feedstock or you use a co-spray technology. This only produces a very much what we call a near net shape, right? Which means the product looks like the final product, but not exactly there yet. So that sort of thing needs to go through extensive machining and post-processing in order to get it to the final shape. But I think this is not in the scope of what we are talking about today, but this is there's a lot of work going on in that space right now, especially for the work that we're doing with the heavy industries in the maritime space.
All right, great. Thank you very much, Dr. Ho. Gary, trends. What trends are we looking at?
I would like to just give an example that might maybe paint a more realistic and easy picture to understand. So we have a strategic partner that we're working with in the US. It's called Divergent 3D. So they basically it's automotive car manufacturer. So what they have represented themselves with 4 words, which is design, print, assemble, drive. So what that means is that they first use what we call artificial intelligence, computational engineering to design whatever design that you need to do. That will be most suited for AM. After that, they print. So of course they have many of our printers, and then they print. And after they print, they assemble it, and they assemble it. I'm not an expert in the robotics parts, but it's all what we call vertical assembly. So they're all autonomous robotic arms that prints it vertically rather than a standard, lengthwise kind of car assembly. And so what that does is that they are able to combine all these technologies into a seamless process. So they're able to scale up and down their production, whether it's 100 units per year to tens of thousands of cars in 1 year. And they're able to change model, change design anytime they want. They are not restricted by a standard assembly line where, let's say, if I have to invest in one line, I must manufacture like 1 million cars in 1 year, in order to make it profitable. So long story short, I think that's the trend that we hope to see, and I believe there will be many companies will be going down that line. It's just a matter of how fast or later kind of thing. But it will reach a stage whereby it's literally that you design, you print, and then after that you have your after so-called after printing process, whether it's assembly or machining, polishing, post processing, and literally that's it. It's ready to be done, and all this will be seamless. And of course, I think what James says, probably with more implementation of all these cobots, that will probably be another big, so-called collaboration technology, so to speak. And so I see that basically as one of the key trends, because AM is not here to replace traditional manufacturing, as some people have mistaken. It is literally here to replace some of the stages, some of the processes, but more importantly, it complements some of the existing manufacturing processes along with other new collaborative technologies, and that's where we see the trend in the future. And of course, industrialization is the key path forward.
All right, great. Thank you very much. Lee Chen mentioned that he has to jump to another appointment already, and we're actually overtime, 7 minutes overtime. So again, Dr. Ho, Gary, to Lee Chen, and to James, I think he just dropped out as well. Thank you very much for your time. Thank you very much for taking time out of your busy schedules to join with us and share your insights. To our audience, thank you very much for joining us. We hope you have learned a lot about what additive manufacturing can do for your manufacturing operations and how it can help you innovate. And we can see that there are quite a few questions that we haven't answered here. But yes, don't hesitate to drop us a note. You can also share your emails here, and then we will share it with our experts. So thank you. Happy holidays, and we hope for a better, healthier year ahead. Thank you very much again.
Thank you very much, Stephen.
Thanks,
everyone.
Thank you, Stephen. Thank you all.
Bye.
Bye-bye.
Bye.